Hello, welcome to our next set of algebra notes. We are on Unit 2, Outcome 5. We solved some equations last time. We're going to solve some more equations this time. The difference here is the equations we're solving this time are going to be equations that involve absolute values. We're going to have these absolute value symbol in them. When you're solving equations with absolute values, one big important thing to note is a lot of the rules that apply with like parentheses and stuff like that don't apply with absolute values. I know with parentheses you can distribute where you multiply things through and stuff like that. You can't do that with absolute values. So with absolute values, our big technique or method is going to be to take the equation that has an absolute value in it and rewrite it as two separate equations that don't have an absolute value, both of which will give us answers because absolute value will have two different ways it could work because of the absolute value. So the rule right here in this gray box is kind of showing you what we're going to do. It says if C is a positive real number, so the C is just a regular positive number, and U is an algebraic expression, so something with numbers and x's and whatever, then absolute value of U equals C can be rewritten or is equivalent to U equals C or U equals negative C. And so both work. That's why we have an or there. So this expression where you have the absolute value of something equals a number is equivalent to, can be written as these two equations. One, where the stuff inside the absolute value, so the U inside is equal to the positive number that's already there. The second, where the stuff inside is equal to the negative number. Well, why can you do that? Well, if the stuff inside here is negative, remember that the absolute values, what they do is they take a negative value and turn it back into a positive. So it's okay if the stuff inside the absolute value is negative C because the absolute value is going to turn that back into positive C. So for example, this is our first example, we want to solve this equation absolute value of x equals 5. So of course it would make sense that x could be 5. That would be a valid solution, right? If x is 5, remember the absolute value doesn't change the sign if it's positive, it just leaves it positive. So the absolute value of x would still be 5 because absolute value of 5 is 5. But it also would work, so the or would be that x could be negative 5 because the absolute value of negative 5 is also 5. So it works because either way, the absolute value of either number, 5 or negative 5, both give us 5. Remember, when you solve an equation, you're just looking for numbers that make it true. So both of these numbers, both 5 and negative 5, both of those would work. Both of those would make this expression true. 5 goes in there and it makes it work. Negative 5 goes in there and it makes it work. So this will work for all absolute value equations. So we'll take the absolute value and we'll say, look at the things inside. You notice how we're kind of dropping the absolute value here. We're looking at just the inside. And say that inside is either equal to that positive number, and it works, or it's equal to the negative of this number, and it will still work because the absolute value will turn it back into a positive. So this is the big trick, big technique, is we'll take the absolute value and we'll take the stuff inside and set it equal to both the positive version and the negative version of the number and get our two different answers. So let's try it. We'll do a lot more examples with this, but that's the basic idea. So here we go, I have another equation. So this 2x minus 3, this whole thing, 2x minus 3, that's going to be my expression, my u. I'm going to say all the stuff inside here is either going to be equal to 4 or it's going to be equal to negative 4. So 2x minus 3, if 2x minus 3, if that equals 4, we're happy because if that stuff is equal to 4, then the absolute value will keep it 4. Or 2x minus 3, the stuff inside could be equal to negative 4. Now some of you are looking at this and saying, absolute value, doesn't make it positive? Wouldn't that make it a plus 3? No, you got to be really careful. Absolute values don't change the addition or subtraction into a different sign. Absolute value takes the final answer you get and then changes the sign. So you have to do the whole product and subtraction first, get your answer, then the absolute value makes it positive. So I do 2x minus 3 and get 4, and then it turns it into positive 4. Well, it's already positive, so it keeps it positive 4. Or I do 2x minus 3 and I get negative 4 for my answer, and then the absolute value turns it into a positive 4. I always get students that look at this and I think they want to rewrite this as 2x plus 3. No, no, no. Absolute values do not turn subtraction into addition. Now, the absolute value of 5 minus 2 is not going to become 5 plus 2. It's not going to become 7. No, you're going to do the subtraction. 5 minus 2 gives me 3, and then the answer is 3. you have to do the subtraction first. You have to do the stuff inside first. So that's why we're just going to take everything that's inside and say that either is going to give us a positive answer, give us positive 4, and we're fine because we keep it, or it's going to give us the negative version. It's going to give us negative 4, and that's when we're going to turn it back into a positive because the absolute value will turn it back into positive. So either way, whatever x gives me that 4, whatever x gives me the negative 4, both of those x's will give me an answer that works. Because the absolute value 4 or the absolute value negative 4, both of those will give me 4. So I'm looking for the x that gives me the 4, I'm looking for the x that gives me the negative 4. Again, these absolute values are pretty much always going to have 2 answers because you have both options. So I'm going to I'll solve each of these by themselves, but this is the big step. The big step is just to rewrite it at the beginning. Once you've rewrite it, then as 2 equations, you just have 2 regular equations to solve, and the rest of it's pretty easy. The big thing is to remember to rewrite it as 2 equations, one with the positive, one with the negative. Okay, here I'm going to add 3 to both sides. I'm trying to get that 2x by itself, so I cancel this. So I get 2x equals 7. I'm going to divide by 2 on both sides to undo this multiplication, so I can get rid of that 2. So I get x is 7/2. So that's my first answer. You know, the 7/2 is going to make it 4. And you can check these. These are equations. You can go back and check them. You can put 7/2 in here and say 2 times 7/2 is 7. 7 minus 3 is 4. And the absolute value of 4 is 4. So you can see it does work. You can always go back and check. Okay, now we have the other option, the other equation where it gives us the negative version. So I'm still going to add 3 to both sides, but this time when you add 3, this negative 4 plus 3 is actually going to give us a negative 1. So 2x equals negative 1. Divide by 2 on both sides. So same process basically, just going to get different answers. So here we have x equals negative 1/2. And again, I can double check this. 2 times a negative half is going to give me a negative 1. Negative 1 minus 3 is going to give me a negative 4. And then the absolute value of negative 4 is 4. So this value works. So you can always go back and you can double check these. You can even type these in a calculator if you want. Remember that your calculator does have an absolute value button. So if you wanted to double check this, you could use the math button and go to that number option as ABS, and you can type it in. You can do 2 times what we had, negative 1 divided by 2 minus 3, and see if it really does give you 4. And it does, it gives you 4. So you can double check it that way. You can plug the number in, see if it works, and just put in the negative 1/2. So that's the idea. We're going to take every absolute value equation that we're given, we're going to rewrite it as 2 separate equations and solve both of those equations and get our 2 different answers. So just like when you solve quadratics, you got 2 answers. When you solve absolute values, expect to get 2 answers. Now, one thing they can do to make this a little more difficult, not a lot more difficult, but just a little bit more difficult, is they can give you extra stuff on the same side as the absolute value. Now, you can't right now rewrite this and say that this has to be positive 2 or negative 2. That doesn't work. Why doesn't it work? Well, if you think about this, absolute value is a positive number. Can you take a positive number and add 5 more and get negative 2? No, you can't. So it's not going to work. When you have an equation like this, you need to isolate the absolute value first. So before you do anything else, before you rewrite or anything like that, first thing you have to do is get this absolute value by itself. So if you have anything like this plus 5 out there, you need to move it out of there. So I'm going to go ahead and just subtract 5, because that will get rid of the addition of 5. And of course I have to do it to both sides to keep my equation balanced. So I can get rid of that 5. So I get the absolute value of 3x minus 2/3 is equal to negative 3. And then you stop and you go, okay, now I got the absolute value by itself. And the temptation at this point is to do your rewrite step. Write it as 3x minus 2/3 equals 3, and 3x minus 2/3 equals negative 3. But wait a second. Did you notice on that first page, they said C has to be positive. Well, why did they say that the C has to be positive? Well, because absolute values only give you positive values. Can you take the absolute value of something and get a negative 3? You can't. It doesn't work. It's not possible. Absolute value only gives you positive. So this does not work. Absolute values equal positives. And so if you ever end up in this situation where you get the absolute value by itself and the number is a negative, you know that this absolute value is not, this equation is not solvable. You can't do it. There is no solution. So it's actually really easy to write absolute value equations with no solution. You just have to put a negative number on the other side of the absolute value. Here I kind of tricked you a little bit because I put a 2 there because I added 5 to both sides to make it look like it was a positive. But as soon as you got the 5 out of there, got all the numbers by themselves over here and the absolute value by itself, then you can see, hopefully, that that's a -3 and that doesn't work. So you can only do the rewrite if it's equal to a positive. Now this isolating is still important. You definitely need to isolate the equation, the absolute value. But if you get a negative on the other side, then you're done. You know there's no answer. Nothing works. I don't care what you put in there. The absolute value is going to become a positive number. It will not become -3. It can't. It has to be a positive. Okay, let's try another one we have to isolate. This one we'll actually be able to solve. So again, I need to get this absolute value by itself. Again, so the first thing I need to do is isolate the absolute value. Again, with absolute values, you cannot do the tricks we do with parentheses. So I can't work with the -2 inside. I can't work with the 3 inside. All I can do is get rid of them. So if I want to get rid of -2, well, that's not too bad. I just add 2 to both sides, right? The opposite of subtracting 2 is adding 2. So that one's pretty easy to get rid of. I have 3, absolute value x minus 5 equals 3. Now again, people get really, really tempted. They try and distribute the 3 here. You're not allowed to do that. There are so many times when it wouldn't work, or if this is, this number might not distribute. So there's no rule for distributing absolute values. None that we're going to talk about. So instead, what we're going to do is we're going to say we can get rid of this multiplication by dividing, because the opposite of multiplying by 3 is dividing by 3, as long as we do it to both sides. Again, you cannot distribute absolute values. Cannot do it. It doesn't work. So really be careful. Do not distribute absolute values. Instead, divide to get rid of the multiplication, and that way you can get the absolute value by itself. Over here we get 3 divided by 3, we get 1. And so now that we have the absolute value by itself, that's the first thing. You always have to get that by itself. Then you can rewrite. So now we can rewrite as 2 equations. One where we say the stuff inside here equals 1. So x minus 5 could be 1. Or the other one where x minus 5, the stuff inside here, is equal to the negative. So -1. X minus 5 equals -1. Either way, we're happy, right? If we get 1 or -1, the absolute value turns it into +1. So both of these are good. They give us 2 good answers. Again, we're going to solve these. So I'm going to add 5 to both sides. That's how I get rid of this -5 and -5. So x equals 6. Add 5 to both sides over here as well. So get rid of this -5. And get x equals, this one gives me 4. And those will be my 2 solutions. Again, you can go back and double check these. 6, like plug it back in here. 6 minus 5 is 1. Absolute value 1 is 1. 1 times 3 is 3. And 3 minus 2 is 1. It checks. You could do the same thing with 4. Plug it in there, it should check out. You get 2 answers. But again, isolate the absolute value first, then rewrite it as 2 equations. One equal to the positive, one equal to the negative. Because either number, the absolute value is going to turn into 1, so we're happy getting either value. I'm happy getting a 1, or happy getting a -1. Either way, I'm happy. Okay. Now that's it really for equations. Equations are pretty straightforward. You just have to remember to get the absolute value by itself and then rewrite. The other half of this section is dealing with absolute value inequalities. These are a little more difficult because now we actually have 2 different situations. We don't just have equals. We have, in this case, we have both less than and greater than. And less than and greater than are going to act differently. So if you, first off, if you have an absolute value is less than a positive number, note this again says positive number, that'll come into play later. If the absolute value of something is less than a positive, that means that this value inside here, yes, it has to be smaller than that number, but it also has to be bigger than its negative. Now, why would that happen? Well, for example, say that a is 10, and the expression in here has to be less than 10. Well, what if the number that x gives you, what if it gives you -20? That's less than 10. Why does that? What would be bad with that? Well, if you have a -20 in here, remember the absolute value is going to turn it into a positive. And a positive 20 would be too big. It would be bigger than a. So that's why we actually have to stop when numbers get too small. They can only go down to -a and only up to +a. So if the number was 10, I have to be below 10, but I also have to be above -10. So like -9, -8, -7, those numbers work because Because when you take their absolute values, absolute value -9 or absolute value -8, those numbers are going to be 9, 8. They're going to be smaller than 10. But if you get too negative, you get all the way down to -20 or -30, when you do the absolute value, you're going to get turned into a +20, +30, you get too big. So this one, when you have less than, so less than, is always going to turn into this between the two numbers, and it's going to be this limited range. I like to kind of call it the cluster. It's going to be between two numbers. It's going to be between, the high point and then the negative version of the high. So it's going to be between those two values. Now the other one is going to be greater than. So greater than, now we're not trying to be smaller than something, we're trying to be above it or beyond it. In this case, there's two options. You can either be big, right? So this is when a number is big. If A is 10 again, say X is bigger than 10, so it's like 20, 30, well then that's great because 20 and 30 are bigger than 10. After the absolute value, they stay 20 and 30. But it also works if the numbers are small enough. So if your quantity is like -20 or -30, that works in this case because now if you take -20 and do the absolute value, you get +20, which is bigger than 10. So in this case, we don't want just big numbers, we also want numbers that are really small because the absolute value of small numbers turns them into big numbers. When I have -100, that's really small, but the absolute value turns it into +100, which is really big. So in this case, the greater than, we end up with not the inside, but we end up with the small numbers going down to -infinity and the large numbers going up to infinity. So that's where we'll just put the two sets together because we have an or, so we'll do a union. And this is our greater than situation. So this will be whatever, low or high number. So we'll say this goes up to the high point and stops, and then it goes up to, it has the lowest number and goes up. Stuff between those two doesn't happen, something like that. So we're going to be a gap in the middle. We have the small numbers and the high numbers. Maybe I should put low and high. That feels kind of backwards, but something like that. So less than is going to be between two values. Maybe I should call this one low and this one high. But they're between two values. And then the greater than is going to be the ends. It's going to be the numbers that are really small and the numbers are really big. It's not going to include the numbers in the middle because that's the stuff that would end up being the less than. Okay, that's kind of the mentality, the idea. All this stuff works just as well with less than equal to or greater than equal to. You just end up using brackets instead of parentheses when we get to that interval notation. But let's go ahead and show one. I think in practice make a little bit more sense than just trying to talk about the idea. So let's talk about what this means. So in this expression, I have this expression, x minus 3, the absolute value of that has to be smaller than 5. So that means this expression, x minus 3, I get a number, it has to be some number smaller than 5. So it could be like 2, 3, 4. So if this subtract and I get 4, like 7 minus 3, I get 4. That works because 4 is less than 5. But this also has to be a big enough number. Because if this expression gives me something like -6, x minus 3 gives me -6, that doesn't work because the absolute value of -6 would be +6, which would be too big. So x minus 3 has to be both smaller than 5, and it also has to be bigger than -5. Now, this is what we call the compound inequality. We saw these previously. Remember, compound inequality just means it's and. It's both x minus 3 is less than 5 and x minus 3 is bigger than -5. So that's what that means. It's saying we have to follow both rules. So we have to be between these two numbers. X minus 3, that expression has to be between those two numbers. Remember when we solve these, we work on all three pieces at the same time. So to get rid of this -3, I'm going to add 3, but I'm going to do it to all three sides. It always feels weird to people because they're like, I'm used to working just two sides of inequality. Again, you're doing two problems at the same time. So you're doing that problem, where you have to add 3 to both sides. And you're also doing that problem, where you have to add 3 to both sides. So that's why we end up doing 3. We're just kind of combining our work, so we don't have to do as many steps. So now the +3 -3 cancels, so we just get x in the middle. 5 plus 3 gives me 8. And -5, or sorry, this is supposed to be +3. It's supposed to be a plus, I don't know why I put a minus there. -5 plus 3 should be -2. So we got rid of the -3, got the x by itself, so now we see that x has to be between 8 and -2. Numbers between those values will work. And you can check this, right? You can check numbers between -2 and 8. I think an easy thing to check is 0, right? Because 0 is between -2 and 8. Does 0 work? We'll plug 0 in here. You get 0 minus 3 is -3. Absolute value of -3 is 3, and 3 is less than 5. It works. could try something big. You could try like 7. See what happens when you do 7. 7 minus 3 is 4. The absolute value 4 stays 4, and 4 is less than 5, so it works. So any number in this range should work. You can check, you can plug numbers in. Now the problem is there's like infinitely many numbers between -2 and 8, right? Because of all the decimals and fractions and stuff. So you can't check them all. But you can always check a couple if you want to make sure. But that's the idea. The numbers between -2 and 8, they are the numbers that work. Again, this is less than. So it's going to be the inside. It's the numbers between. So it's the numbers between -2 and 8. We don't have an equals here. There's no equals, so we're going to use parentheses. Remember, you always use parentheses if there's no equal to, because it means we can't actually include 8. If I try and put 8 in here, 8 is not smaller than 8, so I'm not including 8. I'm using parentheses, and that's what my answer looks like. Again, this is interval notation. And you do need to use interval notation. I had a few people on the test who are like, oh, I don't like the interval notation. I'm sorry, you're stuck with it. It's going to be in our class all semester long. We're going to use it all semester long. If you're really not really comfortable with it, I really recommend going to Khan Academy, Googling interval notation, set notation, watching some more videos on it, doing some more practice, because it is something we use a lot. Okay. Next problem, we got absolute value of 2x plus 5 is greater than 3. So the difference here is not less than, it's greater than. So now we're not worried about things being, trying to keep things small enough. We're trying to keep things big enough. They want to be big. So first off, if the stuff is bigger than 3, we're happy. So if 2x plus 5, if the thing in there is a number bigger than 3, it's going to work out. If I get 7, 10, a million, all those numbers, you take the absolute value of those, they're still bigger than 3, right? Absolute value of 7 is 7. Absolute value of 10 is 10. Absolute value of a million is a million. Those are all bigger than 3. So those would all work. So anything bigger than 3 is going to work. But we also have, or the stuff that's small enough. Remember, it doesn't just have to be big, but you could also have the stuff that's smaller than the negative version. So if 2x plus 5 is less than -3, that also works. The stuff in this set is stuff that's like -8, -10, -a million. Those numbers, when you do the absolute value, turn into positives, and because they're less than -3, before you turn them into positives, they end up being bigger than +3 after you turn them into positives. So like -8 becomes +8, which is bigger than 3. -10 becomes +10, bigger than 3. -a million becomes +1 million, bigger than 3. So stuff that's small enough, stuff way smaller than -3, stuff smaller than -3, turns into big numbers bigger than 3. So that's where we get to our expression. So when we're doing the greater thans, we just have 2 tail pieces. We're going to solve these separately because this is an or, so we can't combine them. And that'll give us the 2 pieces. So first off, this first one, I'm going to subtract 5 from both sides. Get rid of this thing. So we get 2x is less than -8. I'm going to divide by 2 on both sides. So I'm going to get rid of this 2. And I'm going to get x. 8 divided by 2 is 4, still less than, and a negative divided by positive is negative. So numbers less than -4 are going to work. And you can go back and check it. You can pick numbers less than -4, like -6, and plug it in. -6 times 2 is -12, plus 5, that gives me a -7. And the absolute value of -7 is +7, which is bigger than 3. So yeah, I picked a random number and it worked. I just picked something to try. Anything less than -4, you should be able to plug it in and it should work. That's one side. The other side is over here. Now this one, I'm going to subtract 5 again. Of course, now since it's a +3, this gives me a -2 on that side. And if the 2x is greater than -2, I'm going to divide by 2 on both sides. Get rid of this 2 and do multiplication with division. We get x is greater than, well, -2 divided by 2 is -1, right? 2 divided by 2 is 1, and keep a negative because a negative divided by positive is negative. So numbers bigger than -1 will also work. So things like 0, 1, 2, a million, those numbers, if you plug them in there, they'll end up bigger than 3, right? If I do a million, 2 million plus 5 is 2,000,005. After that is 2,000,005, which is still bigger than 3. So anything bigger than -1, that would work. You can make it work. We're not quite done yet, because again, we want to make sure we write this in interval notation. On the test, I will put a little note trying to remind you about that interval notation because it's so important. So you need to remember, read the directions, make sure you remember interval notation. First interval, numbers smaller than -4. So this is going to go from -infinity, because you can go as far as you want smaller, up to -4. There's no equals, so we do parentheses. Other piece, numbers bigger than -1. Well, the smallest we can get is -1. We can't quite reach it, but we get close to it. And then we can go as big as we want. So we go off to infinity because the numbers could be any size as long as they're bigger than -1. Always parentheses for infinity, and for the -1, because there's no equals, parentheses. So when we had no equals at the beginning, I knew it was all going to be parentheses because there's no brackets unless there's an equal sign. And when we had two pieces, we used the union symbol to tie them together. So this would be our answer for this one. So instead of being the stuff in the middle like the previous problem, between -2 and 8, this is all the stuff on the outsides. Stuff smaller than -4 and stuff bigger than -1. The only stuff that doesn't work is going to be the stuff between -4 and -1. So numbers like -2 and -3, if you try those, they won't work. Like if we put -2 in here, that's -2 times 2, we get -4. -4 plus 5 is 1. And absolute value of 1 is not big enough. It's not bigger than 3. The stuff in the middle doesn't work. So we're taking out that junk in the middle that's too small. We only want the stuff that's far out. Far enough out that makes it big. Negative numbers turn big with absolute value. Big numbers already are big. The positives are already big. And so that's why we get the two sets. So we'll do a few more of these, but that's it for this section. This is the equations and inequalities. So the rest from here on out is just some more practice with these inequalities. So here we go. We have absolute value of x minus 4 is greater than or equal to 6. Again, you look at the symbol. When you see greater than, you should think, oh yeah, this is going to be the two pieces with the union between them, right? Where it's going like negative infinity and positive infinity. Because we want to be bigger than or equal to the number, we want to be far out. We don't want the middle that's small. So I know that's what the answer is going to look like just because it's a greater than. That's how I know that. To do this, we're going to say we want the numbers that are really big. So we want things like x minus 4 is greater than or equal to 6. Or the stuff that's really small. The things that get really small are going to be things that x minus 4 is less than or equal to -6. So again, we want the big stuff bigger than 6, and the small stuff smaller than -6. So that stuff is so small, so negative, that when you do the absolute value, you get big numbers. The absolute value of -10 is going to be positive 10. It's going to be big enough. Okay, so that's two pieces. Greater than is always going to be two pieces like this. We're going to solve them, so I'm going to add 4 to both sides. Get rid of this minus 4. So we get x is less or equal to -2. Here I'm going to add 4 to both sides. Get rid of this thing, so I get x is going to equal to 10. So we've got the two pieces like that. Now, because we have our two pieces, solve for x, now I can write them as intervals. So this is numbers less than or equal to -2. Remember, the alligator eats the bigger numbers, so this is the top. So everything from negative infinity until you hit -2, always parentheses for infinity, but this one, because the -2 has an equal sign, we're going to use a bracket here. So remember, whenever you see an equal sign, that turns into a bracket, not a parentheses. Over here we have numbers bigger than or equal to 10, so 10 is the smallest we can get. We're going to go off to infinity, as big as we want. Infinity always has parentheses, but there's an equal, so the 10 gets a bracket. Two pieces, numbers smaller than -2, numbers bigger than 10. Put it together with the union, and you got the whole answer. Got both the left and right pieces. Small stuff, the big stuff. We don't want the middle stuff. We want the stuff that's far out. That's what we're looking for. Okay, let's try another one. This one, I got the absolute value of 7x minus 9 is less than -2, so I see a less than. And you guys are thinking, oh yeah, less than. Instead of the stuff on the outside, it's stuff on the inside. But be careful. There's a trick here. Did you notice what kind of number that was? That was a -2. And in the previous page, when we introduced these absolute values, we said that the number a has to be positive. So just like with the equations, if this number is negative, you can end up with a no solution situation. This is a no solution. Why is it a no solution? Well, because an absolute value is a positive, so an absolute value cannot be less than a negative. I should put just a negative. Any negative. It doesn't have to be -2. It could be any negative. So this is going to be, by default, an absolute value is a positive. You cannot have a positive that's smaller than a negative. It doesn't work. So just like a positive can't equal a negative, a positive can't be less than a negative. So if you end up with this where you have an absolute value less than a negative, so less than negative is no solution. That's the big thing to watch for. Absolute values are never less than negatives because they're positive, and positive are always bigger than negatives. So that's why this doesn't work. So watch out for that. You see the negative there? just like with the equations, that's a big red flag. You go, wait a second, they have a negative number there. That's not good. Okay, got a few more examples to show you. So this one, we want to solve this inequality. We got x plus 8 over 3. It's less than 4. I just want to show this one because it's got like fractions and stuff in it, but it works similarly. This one is still a less than, so it's still less than. So in this case, it is going to be the stuff that's in the middle. It's going to be stuff between two values. There's no equals here, so there will be parentheses. It's going to look something like this when we're done. Just like before, to do this, we take this expression, x plus 8 over 3, and we say, okay, it has to be less than 4, but it also has to be bigger than the negative version. So we're going to say it has to be between 4 and negative 4. So we're looking at the number and doing both the positive and the negative, and saying that this x minus 3 over 8, the expression has to be between those two values, between 4 and negative 4. Okay, now we got our compound inequality. Now we can solve it. We're going to solve this by multiplying by 3 to undo this division, but I have to do that to all the parts. So again, I'm solving this one right here by multiplying by 3. I'm solving this one right here by multiplying by 3. So I'm doing all the parts. That's why I do this. Negative 4 times 3 is negative 12. X plus 8. 4 times 3 is 12. Okay, not quite done because I got to get rid of the plus 8. So I'm going to subtract 8 from both sides. And by both sides, I mean all three sides. So doing all three parts. So I get rid of the 8 on both of them. Negative 8 minus 12 is negative 20. Less than x, less than, and 12 minus 8 is 4. So what this shows us is that the values for x have to be between 4 and negative 20. They have to be in that middle range between 4 and negative 20. So the answer for this is going to be the values from negative 20 to 4, stuff in between. Again, no parentheses, or no equals, so we use parentheses. That's why that's our answer. Now, one thing I noticed on this one, I probably missed on the previous ones, it does ask for a graph. So let's go ahead and just graph this real quick so you can see what this looks like on a number line. On a number line, you'd have, maybe 0 would be here, 4 would be here, negative 20 would probably be way down here. And so you have something that looks like this. And to graph this on a number line, we're just going to have a parentheses or an open circle at negative 20, and a parentheses or an open circle at 4, and then we're going to connect them. And so it would look something like this, or if you use parentheses, it would look like this. So that would be how this number line looks, because when you're doing less than, you're doing the stuff in the middle, not the stuff at the end. So look back, yeah, on this one I said to myself I was supposed to graph 2 and I forgot to, so I'll just show you the graph real quick. If I graph this one, when I have like a 10 here, and say like a negative 2 here, this one, because it's equal to, I'm going to have filled in circles at 10 and negative 2, but this one, because I want the greater than, I want the stuff out far, I'm going to actually go above 10, because this is stuff above 10, and this one's going to go below negative 2. And so that's how it would look like if you're graphing this, and I should have done that then, I forgot to. So that's what it should look like. This would be the graph for greater than, because greater than is just going to be the stuff that's far out. We're missing the middle. Versus a less than we have just the middle, and we're taking off the tails, because we don't want the big stuff. Okay, a couple more examples, then we're done. This one, notice, you see a greater than a negative. You think, oh, I can't do this because of the negative, but be careful. Whenever working with absolute values in equations or inequalities, the first thing you should do is actually get them by itself. So you'll always isolate the absolute value first. Before you jump to any conclusions, isolate the absolute value. In this case, you have to get rid of this minus 4, which is being multiplied, right? So I'm going to divide by negative 4 on both sides. Because by dividing by the negative 4, I can cancel that negative 4 that's being multiplied. When you divide by the same amount, you cancel it out. So that just becomes x minus 3. And negative 16 divided by negative 4 becomes a positive 4, right? Negative divided by negative is a positive. Don't forget when you divide both sides by negative, anytime you multiply or divide both sides of an inequality by negative, don't forget to flip the inequality. This actually becomes a less than symbol. Flip because we divided by a negative. Okay, now we have our true equation, and now you notice this is a positive number. So once we got the absolute value by itself, then we see, oh yeah, we could solve this one. And this we can't solve because we just rewrite it as x minus 3 is less than 4, and x minus 3 is greater than negative 4. Good. Again, with the absolute values, we always say the stuff in the middle, this less than, has to be less than the positive and bigger than the negative. So it's got to be between those two values. Last step, we're going to add 3, and we're going to do it to all the sides. Working on 3 sides at the same time again. Get rid of that minus 3, so we just get x. 4 plus 3 is 7. Negative 4 plus 3 is negative 1. So my answer set is the stuff that's between negative 1 and 7. So my answer is from negative 1 to 7. Again, no equals, so my answer uses parentheses. And you're not done and you write it until interval notation. You'll see it right there. You'll see it in the words that you always want that interval notation. If you just write the inequality without the interval notation, it's not correct. It's not finalized, basically. You're kind of halfway to the answer. You need to be able to describe the set of numbers, and that's what they look like. Okay, one more inequality, and then we're done. So on this one, again, the absolute value is not by itself. So our first step is to get this absolute value by itself. So first thing we're doing is subtract 7 from both sides. And you can probably notice something fishy is going on here, because once I do that, I get 12x plus 5 is greater than or equal to negative 4. Oh, we got a negative on the other side, right? You see that negative. And we know that previously that meant no solutions, right? And so I get a lot of students to tell me at this point, oh, the answer is no solution. I say, oh, careful. This one, the answer is not no solutions. Why not? Well, because now this isn't a less than symbol, it's a greater than. And if you're telling me that an absolute value is a positive, and you're saying the positive is greater than a negative, I'm going to say, well, yeah, that's definitely true. Because no matter what number you plug in, an absolute value has to be a positive, which will definitely be bigger than a negative. I don't need to worry about the equals because it's an or, right? It could be bigger than or equal to. So I'm just looking for this value to be bigger than negative 4, and that works. It does, because this always is positive. So this actually works because an absolute value is equal to positive is bigger than a negative always. So what numbers work then? Well, it doesn't really matter what you plug in for x. So no matter what you plug in, you're going to get a positive number because that's the value, that's what it does. It will be bigger than negative 4. So everything works. So this is always, or all real numbers work. You can put any real number you want in there. We're not going to worry about imaginaries with absolute values. And so any real number you want. In this case, I would say the answer is from negative infinity to infinity. That's that interval notation, right? We said we always have to answer interval notation. And that's the way we write everything in interval notation. So if it's less than a negative, no solution. But if it's greater than a negative, if it's bigger than a negative, then everything works. Because of course a positive is bigger than a negative. You know, that's a given. So we don't need to worry about what x is. We just say this will always work, no matter what you put in for x. So all real numbers work. Okay, so that's it for outcome 5. Outcome 5 is all about solving absolute value equations, absolute value inequalities. So make sure you complete those homework, complete the note, the quizzes, get ready for the exams as they come up. We're about halfway through this section, so that Unit 2 exam will be coming up fairly fast. So just make sure you're thinking about that, getting your formula sheet so you're using that, and you're getting comfortable with it, and make sure you're doing the practice exams and stuff for that test coming up. All right, I will see you on the next set.